Hi guys, so today we're going to take a look at our last method of solving systems of equations algebraically. I'm going to split the substitution method into 2 days, today and tomorrow. We'll look at one type of substitution problem today, and then we'll look at a different type tomorrow. So let's take a look at our first problem and the steps. So on the right-hand side, it says for step number 1 to solve one of the equations for one of the variables. So if you take a look at the example that we already have both equations solved for y. The y is by itself. So we don't really have to worry about step number 1 for today in any of these. For step number 2, it says to substitute in the expression from step 1 into the other equation and solve for the other variable. And I'll show you what that means in a second. And then step number 3, we're going to substitute the value that we found in step number 2 into one of the original equations and solve for the other variable, just like we've been doing. So for step number 2, what we're essentially doing is we are substituting. So for these two equations, they both say y is equal to a certain expression. We have y equals 3x minus 4, and we have y equals 5x minus 6. So if I take a look at the top equation, since this is what y is equal to, and I have a y in that second equation, I could essentially take this whole entire expression and put it in place of the y in that second equation. So instead of having y equals 5x minus 6, I'm now going to replace this y with 3x minus 4, and I now have a new equation. 3x minus 4 is equal to 5x minus 6. And now that I only have one variable within that whole equation, I can solve for x. So first step, normally when we have variable terms and constants on both sides, we subtract the smaller variable term first. So I'm going to eliminate the 3x by subtracting 3x on both sides. That'll leave me with negative 4 on the left. 5x minus 3x is 2x. So I wind up with 2x minus 6 on the right. I want to isolate the x term, so I'm going to add 6 to both sides. I wind up with 2 is equal to 2x, and dividing both sides by 2, I get that x is equal to 1. So I've solved for one of the two variables. The next part of this is exactly like we were doing all last week. We're going to choose one of the two original equations. I'm just going to pick the y equals 5x minus 6, and I'm going to substitute in the one that I just found for x, and then that's going to enable me to solve for y. So I get y is equal to negative 1, making the solution as an ordered pair, 1, negative 1. So all the problems we do today are going to be done exactly the same way. Okay, let's take a look at a second problem. So here again, I have two equations. They are both already solved for y. So I have y equals negative 2x plus 4 and y equals 3x minus 6. So in this top equation, since y is equal to negative 2x plus 4, I'm going to take that expression and put that in for y in the second equation. So in place of y, I'm going to have negative 2x plus 4 is equal to 3x minus 6, and I'm going to go ahead and solve for x. So I'm going to do the opposite of the negative 2x and add 2x on both sides. I wind up with 4 is equal to 5x minus 6. I'm going to add 6 on both sides. I have 10 is equal to 5x. And dividing both sides by 5, we get 2 is equal to x. I'm going to choose one of the two original equations. I'm going to pick the bottom equation. I'm going to substitute in the 2 that I just found for x. And I wind up with y is equal to 0. So my ordered pair, my solution, is going to be 2, 0. So that takes care of two problems. Like I said, these are all done exactly the same way. So when we take a look at number 3, I'm going to ask that you pause it, try this one on your own, and see how you do with it. And when you're done, just come back, and I'm going to go over the solution. Okay, so in this problem, I'm going to take my 4x minus 2 and substitute it in for y in my second equation. So I'm going to have 4x minus 2 equals negative x plus 8. I'm going to solve for x by first adding x to both sides. So I have 5x minus 2 is equal to 8. I'm going to then add 2 on both sides. So I have 5x is equal to 10. And dividing both sides by 5, I get that x is equal to 2. I'm going to take my top equation and substitute in the 2 that I just got for x. And I'm going to have y is equal to 8 minus 2, and that of course gives us 6. So my ordered pair for this solution is 2, 6. Okay, why don't we take a look at this last problem? Again, I would pause the video, try this on your own, and then come back and check your work. Okay, so for this problem, I'm going to take my 8x minus 3, substitute it in for y in the bottom equation. So I will have 8x minus 3 is equal to 4x plus 1. I'm going to solve for x by first subtracting 4x on both sides. So I have 4x minus 3 is equal to 1. Adding 3 on both sides, I get 4x is equal to 4. And dividing by 4, I get x is equal to 1. I'm going to pick my bottom equation to solve for y. I'm going to substitute in the one that I just found for x. And I wind up with y equals 4 plus 1, or y is equal to 5. So my solution for this system would be 1, 5. All right, so that's one type of substitution problem that you're going to see again next year. Tomorrow we're going to practice a different type of substitution problem. And then the remainder of the week is going to be spent making up any missing assignments that you might have. All right, so that is all for today. If you have any questions on any of these 4, please send me a message through Edmodo, and I will get back to you as soon as I can.